So give it up. Yeah, already, yeah. Okay, going fast. Going fast. Okay, stretch a bit, stretch a bit. To each other. Okay, going fast. Okay, sit down. Who is not here today? Mitra, Jaden Loy. Huh? ISO? Ethan To. Because of appointment. Medical appointment. Scan the MRI. Okay, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 7 people. Isaac Jukai, Mitra, Jaden Loy, Ethan To. Huh? Edison and Javier. Javier to support today. Okay. Okay, come. When you're ready, can you take out your practice set 1 and 2? All have? Anyone don't have? Don't have. When can I have it? Do now. Okay. Yeah. All have. No one don't have. Have I written you? I thought I written you. Have I written you? I thought I written you. 2 you gave me already, I remember. Yeah. You gave me 1. Okay, that's fine. You did it, eh? You did it, huh? You did, 1 you did already. 1 or 2? Okay. Both. You also both. Or if you did it, then it's fine. If you did it, it's fine. Yeah. Okay. Okay, ready? Okay, let me just show the answer to you one by one. This is practice set 1. Very easy one. Other classes have gone through it like last week. We are doing it now. Okay, yeah. But because I'm at my own pace at my own time, I'm not competing with other teachers. Huh? You know, I all play this game, all never bring that same, you know. Huh? Okay. I think so too. If I find out you never give me, I will shave bus cut you. Huh? Okay. Any question? Doctors have? Have. So don't have? Don't have. You gave 1 to me. 2 also. Okay. Any question that you need me to go through? 1 loop, 2 loop, 3 loop. Ethan, you I remember. Because Ethan, you first one. Don't have? Megan, I remember. Megan was first one to give. Megan was first one. Don't have? Ariel don't have? Oh, didn't bring. It's fine. Okay, practice set 2. Practice set 2. X equals to 4, x equals to 0. Help me to mark as well. You found it? Then you say pass B. Okay. Okay. So 1B. One C. If you never bring, at least write down the answer. So that you go home, do it, you can mark. Joshua got do? Do already. Is there any question you want me to go through? Your piece one we mark already. So likelihood, I think either this Friday or next week we'll give back. It should be next week, lah. Okay, it should be next week, next Monday like that. Yeah. Okay, so manage your expectation, lah. Manage your expectation. This time around, I think if you pass, it's quite good already. Okay, quite a lot of failure. Through the whole cohort, through the whole cohort. Okay? Can yeah. The A's are also lesser than usual. But if you pass, generally you are, I think, should be above the cohort mean. I think. Median, not mean. It's about 50. Yeah. Most of us are in in the 20s to 30s range. Yeah, there are a few who are 40s, or there are a few of 40s. Okay? Like me, I'm 41 years old. Okay. Most of y'all are very young. So your marks are as young as your age. Huh? Okay, sorry. It didn't not meant. But just know that it's about 20 plus to 30, right? Okay? Can yeah. So have the expectation. Don't cry out when you all see you all cry, I get very stressed. Okay? Yeah, slowly go down. One air. 1, 3, 3 or square root 3. This one reject, remember? Even if it's rejected, you still must write down. Okay, don't just keep the answer. Okay, even if reject, must still write down. Must still write down. Must write down. Must write down. Hey, you okay now? You like, oh, auntie, like that. You look like your back going to fall into half. Yes, because if you sub in the left hand side, right hand side, not the same. Or in fact, if you start with the equation, right, the fact that this is equals to a negative modulus, it should be 2x minus 3 needs to be more than 0. Therefore, x has to be more than 3 over 2. Therefore, x cannot be negative square root 3. Can okay. So I go to 1G. Is it okay? Okay. If you never bring, you copy down the answer. At least you got some security. You go back home, can mark. Okay, that's the least you can do. Last time as I was a student, whenever I tired, I just keep moving my hand, copying notes, even when my brain wasn't moving. So at least like that, when I keep moving my hands, I will stay awake. Okay. Okay, some of you are writing and looking at the board, so I'll wait for a while. Friday will be practice set 3. Can Can? Yeah, practice set 3 will take a while because got a lot of graphs. Graph. Okay, slowly go down. Slowly go down. 1G. 0, 6, or 2. 2 you reject. 2 you reject. Okay, but for 2, it's you write down the reason. Don't just keep the answer, so you write down the value. Okay. Practice set 1 and 2 will take you about say 30 minutes if you haven't done. It's pretty fast. Okay. No, nothing to go through. Don't have. Okay. 1, 2, 3. 1H, 2 or -1. This one you need to factorize. Do not break into two cases. You factorize, you realize that they are scalar multiple of each other. Here, they are scalar multiple of each other. 2s minus 1, 6s minus 3 is the same as 3 units of 2s minus 1. Finally, you get 2s minus 1 modulus equals 3, 2s minus 1 equals 3 or -3. Okay? Yeah. Just take note of the homework deadline and put on the board. Okay, practice set 1, I will try to send you all the question by today. Okay? It's pretty fast. It takes you half an hour to do. Hey. Huh? Why you forget to? Why you forget to? Yeah, then you are going to so I got C students for this 2 plus minus, estimate the plus minus, then working on page long. So it's 2%. Whenever there are two modular signs, try to consider whether they can be brought together. Okay? Okay. Okay, so 1H. 1H. So lower your expectation a bit. Okay, this one every whole cohort be very bad. Even those classes that usually got whole class got A1, never whole class get A. Okay, only about half the class. Some classes half the class fail. Okay, so if you got 20 plus, this time now is good already. Okay, if you got 40, it's very good. You are a genius. Okay, our class got people get 40 and above. One or two. Okay. Yeah. Error carry forward. Who's error? Huh? Go. But error if only if there's M1, A1. What do you mean? Have. If it's logical, yeah. Anyone want me to go through? Yeah, you don't need to be too, you can be passive, you just say go through, I'll go through. Don't have. Okay, then continue. Okay. Question 2. Question 2. Sorry. R4. Oh, okay. I think. Okay. Okay, so question 2, they tell you that F2 equals to F -6. Okay? So you start. Again, remove the modular sign, plus minus from both sides. Okay, when you have two modular sign, remember you can split to plus. If it's just two of them, that's easy now. It's either F equals to G or F equals to G. Okay? Remember this from here, what we talk about is that if mod F equals to mod G, then F equals to G or F equals to -G. Okay? Okay, some of you are looking, so I pause a while. Which one? P equals to 2. 2 equals to okay. And, the right hand side, if you work, you'll find out it's rejected. Because it doesn't work. Because if you have plus minus, the minus part, then let's say you get 2 equals to -6. So that don't make sense. Yeah. What? You need to go up. Or go up. Here. Up. Wait a second, string. Okay. Itu ya. Okay. Two minus p. Two minus p equals to p plus 6. 2p equals to. Okay. Oh, wrong. You're right. Okay, let me check. Thanks. 2 minus p equals to p plus 6. Can I check the question again? 1 second. 2 minus p plus q. 2 minus p equals to 6 minus 6 plus p. 2p equals to 6 minus 4. Yeah, 2p equals to minus 4. So p equals to minus 2. Correct? Yeah, minus 2. Minus 2. Yeah, minus 2. Thanks. 10,000 points, doctors. Okay. Thank you. The rest okay? If all okay, then we will can pass to me or pass to Sitong. Okay, how? So the AFL one is with me. Sorry, okay, mistake. Okay, so just remember this deadline. Tuesday, practice set 1, Wednesday, practice set 2, next Friday assignment. 可以吗？ Can Is it unreasonable? It will be okay. So it will take you like 30 minutes to do one practice set. Okay. Then okay. If all okay, pass up, then let's go back to the notes. Okay. Where did I last stop? May I check? Just show me where you are. You all never make notes? All have, Okay, take note of the deadline. Okay, let's come back to the notes. Where did your last stop? Are you? Oh, how come you are at 1 point? Of course, you never bring notes. Okay. 2.5, Are you at 2.5? Oh, around 2.5. Where are you at? 2.5. Where are you at? 2.5, 2.5. Okay, so I start on part 3. Yeah. Okay, part 3 basically the derivative of the logarithmic function ln x is just equals to 1 over x. Okay, again, I will not go through the proof. Okay, but what you need to know how to apply it. Okay, ln, you must remember, this is not the same as log, they are of different bases. Ln is the natural logarithm. Okay, natural logarithm. The derivative of ln is 1x. Okay, but so this is O level. This one is A level, H2. Okay, if you are differentiating log AX, that is the same as 1 over x log A, or equivalently 1 over x log AE. Okay, y'all. Are y'all aware that these two are the same? No? Okay, y'all remember change of base, right? So here, I want to recall change of base. I'll recall logarithm, change of base. Okay, when you have log AB, you'll remember this is the same as log B on top, A below, change to base. Okay? So what am I trying to say is that 1 over log A, can I say it's the same as 1 over log base E of A? Can I? So you remember one of the spin-off cousins from this is that 1 over log AB is also the same as 1 over log BA. Change of base logarithm, MA 300 topic 3. This one okay? This okay? Not okay, just tell me not okay. Let's see it then. Withdraw. Okay, now, okay, so because of this change of base, right? Logarithms, change of base on logarithm, I can say that this is the same as log 1 over log A is log A. That is why you see in brown, 1 over log A is log A. Okay, 1 over log A is log A. Okay, just to make it clear. See, okay? Okay, now let's give 3.1 a try. 3.1 a try. Okay, 3.1. Can okay, so I erase. For 3.1, you can consider maybe you let y to be ln x. Okay, then this will imply that x is just equal to e power y, right? I change from logarithm form to exponential form. Okay, after that, if I differentiate both sides, I differentiate both sides with respect to y. Differentiate both sides with respect to y. Dx dy will just be still e power y, right? Remember, we can differentiate respect to y, not just x. Or then what does it say about dy dx? Remember, dy dx, right, is the same as 1 over dx dy. Remember this? Because you treat like a fraction. You treat it like a fraction. This is the same as 1 over e power y. Okay? What is 1 over e power y? You observe here. Remember your y is ln x, right? So this is the same as 1 over e to the power of ln x. What is e to the power of ln x the same as? E power ln is the same as? Yes, it's the same as x. That's why it is what it is. Okay? Okay? So if okay, then you all can keep 3.2 a try. Okay, B equals to IR. Okay, yes. Oh, from here to here, right? I'm changing from the logarithmic form to the exponential form. Because if you recall in GH3, right, when at log form, okay, if y equals to a power x, this is called the exponential form, correct? So in the exponential form, this converts log ay is equals to x. This is the logarithmic form. This is the logarithmic form. Okay, huh? Can, huh? Remember the story I think that time? Right? There's a bridge, there is a tree, there's a bird, there's a woodcutter. Right? So this is the woodcutter. Woodcutter. This is a bridge. This is a tree. This is a bird. Okay, bird is on top of the tree. Okay, bird is on top. Okay, tree. So woodcutter take the tree, cross the bridge. So the woodcutter take the tree, cross the what the tree become? If I chop the tree, become a log. So this tree you have cross over a log. Log means A. Why? Bird got nowhere, right? Bird got no more tree, right? Bird got no tree where the bird sits on the floor. Okay. And okay. Zoe, are you okay? Sick. Okay. Does the log? No, doesn't. It only works for log x. It only work. You mean what the first rule? This one. You can see that these two are different. This one is base E, this one is base A. If it's log x in general, it will be this. Okay, over x log A or log x. Yeah. And another two new formulas to add to your list. Which one? Oh, okay. So this part is okay. This part is okay. Yes, dy is okay. This part okay. So okay, if A is equals to B, if A is equals to B, 1 over A is equals to 1 over B. Can I say that? Okay. So if you get it, yeah? Okay, so if dx dy equals dy, then 1 over dx is 1 over power. Okay? Can I? Okay. So now let's go to 3.2. 3.2, all you need to do is do change of base. Change it to ln x over ln A. Okay? So you conduct a change of base. Change of base. Change of base to base. Okay? To obtain the natural log. The natural logarithm. Okay? Hopefully that gives you some idea. That gives you some idea. Oh. Yeah. 2.48. 30 over 2x plus 9. Over 2x plus. Do you bring the 15 down? Yeah. Yes, that's good. Then it's 2 over 2x plus 9. You have to do the chain rule for the sign. Yeah. Oh. Let me write the answer down since you are so fast. Okay. Question 3.B. Okay, yes. 3.38, why is it 1 over x? Okay, so first I go through this portion first. When you take ln, okay, first of all, I know ln I will get 1 over fx, right? So differentiating ln of fx, right? Again, I just want to sell it to you from my point of view again. Okay, so ln of fx, you can see that there's an outer layer, there's an inner layer. You see, okay? Can huh? So if we differentiate the one in brown, that's the outer layer, the one in green, right? Differentiating the one in brown, red color, that's 1 over blank, right? Right. Differentiating the one in green, that will give me f prime x. Can huh? So that's why my answer is f prime over fx. Okay? Can similarly, because if I differentiate here, there is a one in brown. Differentiating the one in brown gives me 1 over fx ln a. Differentiating the one in green, that's what gives me the f prime. Okay? Again, I'm using chain rule. Oh, so there are many formulas. There are many formulas to remember. 可以吗? Need to slowly take it all in. Write it down, then put it on the okay? Can I? Okay. Question 3.3a. So if you look at 3.3a, you have f prime over fx. Am I right? So if you see, this is the fx, right? What is f prime? 5. What is fx? 5x. Cancel 1 over x. Because of cancellation. Okay? Yes. 3.2. How to do 3.2? For 3.2, what you do is you change it. Can I say that by change of base, this is ln s over ln a? Okay, let me make it more obvious. I change it to log ax is the same as log x log a of base. Okay, log e is the same as ln, so it's the same as ln x over ln a. So Zoe, ln a is just a coefficient constant. Am I right? So if I'm differentiating this, it's the same as differentiating 1 over ln a, differentiate ln x. See, okay? Because it is after all just another coefficient, right? Yeah, so it's just a constant. So I can put it outside. And differentiating ln x gives me 1 over x. Ln a, I just copy paste. And that is why my answer is 1 over x ln a. That simple as that. Just by using change of base of logarithm. Okay? Can? Once again, where am I? This is employing using change of base of logarithm. Okay? Can any issue? I remember dy du is y is a function of u is a function of x. Okay, so but I seldom teach it this way because I think it's confusing. Okay, but that's how the textbook does it. Okay, because this is like something like you see it's like cancel off, then you get dy over dx, right? So how they see is, for example, say let u equals to fx, then y is equals to ln u. So based on this, right, dy du, right, is 1 over u. Then based on this, right, du dx is f prime. That's why dy dx is dy over du times du over dx, which is like f prime x over u which is f prime x over fx. Okay? And but usually I prefer to jump for outer layer, local layer. 比较快而且比较简单。I don't need to think of what a layer in the function in the function. Yeah. Then the later the brain cannot function. Okay. Okay. Yeah. Go fast 3.6b. 3.6b. Okay. Part 1 is it? Part 1. Why is it minus 1 over 4? Because of the minus sign outside, I believe. Yeah, minus sign. Yeah, apparently so. Apparently, I think it's 5 over 2. Is your bottom 20,000? 5,000 or 20,000? Oh. Oh, yeah, yeah, yeah. Right. Huh? Oh, yes. Thank you. Okay. Okay, can so yeah. How do I arrive at? Because ln A is a constant. Ln A is a constant. So ln A is like, if I divide by 3, whenever I differentiate x over 3, the 3 I can put outside. Right? So if I'm differentiating this, right, this ln A can be left outside. So when I'm differentiating, for example, ln x over ln A, right, I want to bring to your attention that this guy is a constant. Do I have an example? Let's say if I differentiate, okay, we I ask you if I differentiate x squared over 7, is this the same as 1 over 7 of differentiating x squared? Fair to say so. I mean, differentiating x squared over 7 is what? 2x over 7, right? Is it the same as 1 over 7 times 2x? Cannot, because in differentiation is distributive, is associative. Scalar multiples can be left outside. Constant scalar multiple can be left outside. We call this a constant. Now, if you're not sure, then I ask you. Remember in topic 1, you differentiate AFX. This is the same as A differentiate FX, right? Fair? Fair. Is this one okay with you? So now I add something. If I differentiate x squared over ln 7, is it not the same as 1 over ln 7 differentiate x squared? Okay, right. Then if I differentiate, now you know what I'm going, x squared over ln A. It's also the same as 1 over ln A differentiate x squared. Okay? Can I? Yeah. 3.3 part C. Okay. 3.3 part C. Good. Okay. I give you an idea, okay? Can I? The idea, the hint is this. Ln A over B is the same. Hint number 1, ln A over B is the same as ln A minus ln B. Hint number 2, ln 1 is 0. The idea already? Okay. Can anyone else start any part? Yes. You change to ln 1 minus ln 2. So you do this. When differentiating log, right, try to use log for logarithm first. Yes, sorry. can is can. But remember, if it's a constant, right, you don't have to use quotient rule. Okay, guys, if you're doing 3.3c, can I show you all something? Okay, many of you might have done this. Look at this. Look at f prime fx as 1 over 2x. And then you all do something like this. Differentiate 1, 0, 2x minus 2, 1. You all do this? No need, nah. You know what I'm going to do? Very simple. Whenever you can you just write this down somewhere? When differentiating log, it's always a good idea to think about loss of logarithm first. Okay, that's the pattern of the questions. If you go and look at revision package, we would like to set one question that differentiate log, but for use of loss of logarithm inside. Okay, what am I trying to tell you? This is the same ln differentiating ln 1 over 2x is the same as differentiating ln 1 minus differentiate ln 2x. Differentiate ln 1 is just sleeping beauty. Differentiate ln 1 is, what is ln 1? 0. Differentiate 0 is 0. Okay, so can I just say this is the same as differentiating negative ln 2x? Like I was telling myself just now, negative is a constant coefficient outside. Differentiating negative ln 2x, negative 2 over 2x. So bias, you can see, I had such an easy line. Cannot? 2 over 2x. I can even go further. Well, I can even go further. You know, Joshua, if you love your logs, right, your logs will love you back. Can I say that this is the same as differentiate ln 2 plus ln x? Differentiate ln 2 is 0. Differentiate ln x is minus 1 over. See. Yes, yes. But if it's x plus something, then cannot. If it's like something like this, then cannot. Like this one, then cannot. Then cannot cancel. Okay, is that okay? Similarly, for 3.4, I hope you do this first. Write it as 15 ln 2x plus 9. Okay? Because you are applying the power law. Apply the power laws of logarithm. Okay? I tell you what, as I was teaching this, I also came to my realization that you all might forgot. So, laws of logarithm. Laws of logarithm, right? The first one is the product law. Product law says that the addition of 2 is the product of 1. Log ax plus log ay is the same as log a xy. Okay? Quotient law. Log ax minus log ay is the same as log a x over y. Okay? Power law, log a x power r is the same as r log a x. Okay, can I take a photo? You want to log a is just 1, log a y just 0. Okay, change your base. Log a b over log a b is the same as log a b over, sorry, it's the same as log c b over log c a. 1 over log a b is the same as log b a. This is the change of base. Okay, and I just write here in case you need. Okay, so question 3.4. No, wait. Okay, write this first. This is the same as 15 log 2 over 9. Power law. So dy dx is just 15 times 2 over 2x plus 9, which is 30 over 2x plus 9. Okay. Sorry. Okay. How to say? Good. You're very smart. Say very smart. Okay, Part D. Oh, 3.3. Okay. 3.3 part D. So 3.3 part D, 1 over ln 2x. 3.2. Not there. This one unfortunately I cannot do anything because this one you can see that these are different. Right? This one I can use power law, this one I can't. I can't apply any laws. Because this is the same as y equals to log 2x entire power minus 1. Is that okay? Can I? So now you can see that got layers now. Got layers now. So then, so Zoe, what I'll do is now I see this differently. Layer 1, layer 2, layer 3. Can? Huh? Yes. How to do 3.4b? I give you a hint. Give you a hint. I don't know that. But do you know do you do A using this method? Same. I'll give you two hints. Number one, ln A power R e power x is the same as R ln A plus x ln B. Decompose it. Can? Can I? Can I? Can I? Yeah, very easy. It looks difficult, but it's actually very simple. See how okay? 这样 for 太容易了too easy for them. So okay? So is doing topic 7 already. Okay. C. So it's really quite easy. Okay, guys, use laws of logarithm, okay? If you never use, I'll be very disappointed because I think I just want you to work so hard. Okay. Chloe is easy. Chloe is having a good life. Okay. Elenis cannot see. Elenis got the setback over the gun. 3.5 part I. 3.5 part I. I differentiate gx. How do I get secant x? Okay. Differentiate secant is secant tangent. Just a reminder, when we differentiate secant, that is tangent, is secant tangent. Okay? Differentiate tangent is secant square. Okay? Secant and tangent, they are both very secanting one. A lot of secant inside. Secant, secant, secant. Okay? Can Question 3.5, part I. If I differentiate ln of secant x, right? Remember, this is f prime, right? This is f secant x tangent x at the top, f prime over fx. What's going on? Which is the same as tangent x. Okay. If I differentiate ln of secant x plus tangent x, that will be secant x tangent x plus tangent x over secant x plus tangent x, which is secant square x, sorry. which is the same as secant x tangent x plus secant x over secant x plus tangent. Cancel, cancel, then you are done. Okay. Question 3.5 part 2. Find the equation of the tangent at x equals to pi over 3. Equation of the tangent at x equals to pi over 3. So that means what? You see here, if fx equals to ln secant, f prime is equals to tangent. If f prime equals to tangent, f prime for pi over 3 is tangent pi over 3. Okay, what is tangent pi over 3? I think it's square root 3. Square root 3. Okay. Then after that, using the formula, what about y? So x1 is equals to pi over 3. What is y1? Y1 would be ln secant pi over 3. Ln secant pi over 3 should be the same as ln 2. 1, 2, 3. Okay. From here, then employ the equation. What's the equation of tangent? Equation of tangent will be y minus y1 equals to gradient x minus x1. So y minus y1 is ln 2. Gradient here is square root 3. X, this is pi over 3. Simplify, and then that's where you will get y equals to square root 3x minus pi square root 3 over 3 plus ln 2. This is the equation of tangent at x equals to pi over 3 for fx. Okay, can? And I know it's not easy. Do it slowly at your own pace. At your own pace. This lesson, you can do up to 3.5 is good enough for me. Okay? Yeah. Still got 15 there, huh? Because the 15 is a power. It's a power. So by the power law in logarithm, the power can become a coefficient. So that means when I differentiate when I differentiate ln of 2x plus 9 power 15, this is the same as me differentiating 15 ln 2x plus 9. Yes, and then 15 is a coefficient. It doesn't matter. I can put it outside. On ln 2x plus 9, which is the same as 15 times 2 over 2x plus 9. That gives me 30 over 2x plus 9. 可以吗？ Can easy lah. Differentiation of log. Actually, once you apply the laws of logarithm, it's very simple. Yeah. For which one? 3.5 but I. Oh, when the two tangents meet, I just double check. Your first tangent is it? This is the first tangent for fx. For the second tangent for gx, the equation of tangent at x equals to pi over 3 for gx, g pi over 3 is, okay, y is equal to 2x minus 2 pi over 3 plus ln 3. Is that correct? Then you equate these two together. Is that correct? Cannot. Is that what you got? No. No. Slowly. It's a very disgusting expression. 3.6, I'll just fall in a while. No, this is very hard. We need a lot of time to go through. Yes. How did I get ln 3? Okay, so you substitute for gx, right? Gx is equals to gx is equals to what? Ln secant x plus tangent x, right? Okay, so g prime pi over 3 is ln secant pi over 3 plus tangent pi over 3. Is it okay? Secant pi over 3 is the same as 1 over cosine pi over 3. Cosine pi over 3 is square root 3. Oh, so this is the same. Okay. So this is the same as 1 over square root 3. Is it okay? Can I? Tangent? No, correct. Correct. No. Tangent. Secant pi over 3 is wrong. Secant pi over 3, 2 over square root 3. Okay? Cannot lah. Okay, cosine pi over 3 is the same as square root 3 over 2. Correct or not? Cosine, cosine pi over 3 is cosine 60. Square root 3 over 2. Are you in the wrong mode? So secant pi over 3 is 2 over square root 3. Okay? What's wrong? Pi over 3 is 60. Oh, half. You're right. Sorry. I stupid. Yeah. Okay. Then what is tangent pi over 3? Square root 3. Okay. That is the answer. Okay. This teacher made the mistake again. Yeah. Okay. Hey, let me try. Okay, let me do again. Yeah. Okay. So let's try. So y minus y1 equals to x equals to gradient. No. Y this is g x. Okay. So what is g prime pi over 3? It's the same as what's your g prime pi over 3? You get yes. 10. Okay. Ln 2 plus square root 3. No, that's G. You ever do? Okay, then I do myself. Okay, then secant x. So that is secant pi over 3, which is the same as 2. Okay, huh? So therefore, y minus y1 equals to gradient y minus y1 equals to gradient x minus x1. So therefore, y is equals to 2x minus 2 pi over 3 plus ln 2 plus square root. Is it okay? And after that, we equate. Now this is equation 2. This is equation 1. Okay? Now you solve simultaneously. Square root 3x minus pi square root 3 over 3 plus ln 2 equate to 2x minus 2 pi over 3 plus ln 2 plus square root 3. Okay, sorry for being so dry. It's a very tedious answer. So now I put these two as the subject. Okay, I mix the subject. Okay, so I put these two together. Square root 3 minus 2 of x equals to pi square root 3 over 3 minus ln 2 minus 2 pi over 3 minus ln 2 plus square root 3. Okay, think fast. And then combining these two together, I have pi minus, square root 3 minus 2 pi over 3. Combining these two together, I believe I can fly. Okay, so I believe it's ln 4 plus 2 square root 3. This is x. Then divide by square root 3 minus 2. Okay, so this is, you see, if I cancel, this will be pi over 3 minus ln 4 plus 2 square root 3 over square root 3 minus 2. Okay, I hope I got the answer correct. Okay, yes. 3.4 part C. 3.4 part C. Let's see. Okay. Oh, she smiled. You can see, you can, okay. Of course, you smile, your eyes will change. Okay. 3.4 part C. Okay, I give you an idea. Give you an idea. Ln in A over B is the same as ln A minus ln B. And after that, what do you do is second hint. 6x squared minus 13x plus 5 is 2x minus 1, 3x minus 5. Yeah, here we are. Come over. How will you know? Let's say you know it's 65. You'll still be able to factor later on. It's also okay. It's okay if you never factorize. It's okay if you never factorize. Also, even if you combine the answer, it doesn't change the meaning of the answer. Yeah. So if you look, let's say for C, wrote something like log 3 over 3x plus 1 plus 12x minus 13. 6x squared minus 13x plus 5. By right, they cannot follow. You take your, because if you, unless, if the question 1, right, they will tell you, put the answer in the form of this partial fraction. They'll tell you in this form, linear fraction form. Okay, yes. How do you go wrong? Oh. Last time I was in the forest for reservists. We were getting evaluated. Then I had a assessor. So the assessor was very strict, but yeah, but we were all like old men. So I bought him McSpicy. So we were in cemetery. So I went out of cemetery, then I bought the McSpicy. The person really come. At that time I had to pay extra money just for him to come to the cemetery to deliver the McSpicy. So I told the McSpicy, I gave to my assessor, hey, I think you look very tired there. Next day he outside also. But after that I got A. Yeah, after that I got grade A. Yeah, so it's a It's a story about how McSpicy can save the day. Okay, anyway, yeah, let's go on. Okay, question 3.3. Huh? Which one? Yeah, last time there was no Grab food my time. So it was like back delivery. They already got. Okay. Yes. 2.5. Oh, that was very hard. Very hard. Okay. Let me slowly show you. 4 part. The first part. The first part. First part. Okay. So you differentiate secant is secant tangent. Is it okay? Then you then this is f prime. So secant less than below is fx. So this is the same as f prime over fx. Okay? Can it's the same as f prime over fx. Oh, can so this is f prime. This is fx. No. Or you can write 1 over secant times secant tangent, is it? No, no wrong with you. Then the answer is sectangent. One more time you turn around. Okay, when you differentiate ln of fx, right, is f prime over f, right? So if this is fx, f prime, you differentiate secant is secant tangent. Can you proved it before. You proved it before. I just want to let you know. Yeah, because math is accumulative. Math is accumulative. It's like a credit card bill. It's just snowball. It's snowball. No, snowballs. Okay. What am I talking? Make us see properly. You see, like you go to Humpty Dumpty fall off the wall. Okay, so then there, bro. See, secant x is secant tangent. Can? Are you okay? You look like you cheating at hand. Can Okay, let me just go around and see your